Alrighty, this is a problem where I want to approximate a square root of 24 using Newton's method of linearization or with differentials. I'm going to start with differentials and do this video on differentials, and then I'll do another video for you on using the method of linearization. In this case, because of the nature of things, we wind up getting the same answer with either of them, but I'll show both. So, to do it with differentials, I want to recognize, alright, I'm working with a square root of a number. So I'm going to take my function that I'm going to work with as y equals square root x. I'm going to use, to approximate the root 24, I want to find a number near 24 that I can root easily. I know that I can square root 25, so I'm going to take x equal to 25. And then I need to know how far is 24 from the 25. So it is 1 less. So my change in x to get from the one that I know, 25, to one that I want to know, 24, is equal to negative 1. If, say, this was 23, then I would want to use a delta x of negative 2. So, from there, I want to find dy dx of this, and I write it as dy dx. It's equal to, so that's square root of x, which is x to the 1/2. I'm not going to show this work because you should know it, and you should be pretty familiar with it. So it's x to the 1/2. X to the 1/2 gives me 1 over 2 from the 1/2 in the powerable part, and then times x to the negative 1/2, which is over square root x, like that. So I've got 1 over 2 root x. So now what I'm going to do is rewrite that as dy equals 1 over 2 root x times dx. So from here, all I have to do, the approximation is going to come from the dy, or the change in y. The dx is going to be my delta x, and my x equals 25 goes in as the root. So what I'm doing there is I'm gonna figure out how big the dy is for the 25 with a dx of negative 1. So I'm gonna get dy equals 1 over 2 root 25 times negative 1, which gives me 2 times, I get 1 over 2 times 5, which is 1 over 10, and then it's negative, so it's negative 1 over 10. So what that tells me, and that's 0.1. So what that tells me is that that the square root of 25, or sorry, the square root of 24, based on this, is 0.1 less, or our approximation is that it's 0.1 less than this guy right here, or the square root of that right there. So I take the square root of the 25, which is 5, and then I add the dy, which is negative 0.1. So minus 0.1, which gives me an approximation. So root 24 is approximately 5, which is the root 25, minus 0.1, which is equal to 4.9. And if you try this on your calculator, if you type in root 25 or root 24, you'll get a number that's very close to this. So actually, it's a really good job.